Hi guys. So today we're going to be talking about scientific notation. Now, scientific notation is something that I think some of you have some experience with, I hope. I assume a lot of you do. At the same time, I'm sure some of you, this is kind of like it's kind of a new thing. It's something that you're not as, or maybe not new, but it's just something you've never been that comfortable with. So my goal today is basically to just, I want to walk you through this and I want to make sure that by the end of this is going to be short. I'm going to keep this simple, straightforward as possible. By the end of this little lesson, I want to make sure that you're able to uh, basically convert numbers from decimal form into scientific notation and also go the reverse direction and convert from scientific notation back to decimal form. We want to do that. So, to begin with, why do we care about scientific notation? The big thing in chemistry is, and especially in chemistry, is that you are going to be dealing with some really, really, really big numbers and some really, really small numbers. So, one number that you'll see, I'm not going to write the whole thing out, but it would be 602. Then there would be 21 more zeros after this, just 0, 0, 0, 0, 0, 0, 0, 0, etc., etc., etc. Now, that number, that's not a fun number to write out. I assume nobody actually wants to handwrite that ever, and I don't blame you. Instead, you just write it as 6.02 times 10 to the 23rd. That's how this would actually be written. This is much easier to deal with than that. It just is. So that's why we do it. At the same time, there are some really, really small numbers that we have in chemistry. Um, and again, I'm not going to write out 34 zeros, but imagine that you had something, you had 0.00000, and then 2, 6, like, so there's 34 zeros and then 626 or 624 or any, incredibly small number. Instead, we just write it out 6.26 times 10 to the negative 34th. That's pretty much the biggest number you're ever going to encounter in chemistry and the smallest number you're ever going to encounter in chemistry. So there are some huge ones, there are some small ones, and there's a lot of stuff in between. So what we're going to be dealing with today is just nothing this crazy. I'm just showing you why this exists and why it's taught to you. What we're going to look at today, basically, though, is just how to do this very simply, how to make sure that it's not a problem for you, and just how to convert numbers. So to begin with, let's just look at any old number. Let's say we have one. We'll say 1,500,000. Sorry. So you've got 1,500,000. Big number. What we're going to do now, we're going to convert this to decimal form. So we're going to convert this to decimal, or no, sorry, it's in decimal form. So this is in decimal form right now. We want to convert this to scientific notation. So how will we do that? Well, we'll keep this really simple for you. So basically, in this case, in this number, there's not even a decimal point given to you. So the first thing you want to do, you're going to put a decimal in there. So if there's a number where there's no decimal, add it at the end. If there is a number with the decimal, then good. You start from the decimal point. And the goal of this, of scientific notation, basically what we want to do, we want to take this very large number and we want to turn it into a number that is greater than 1 but less than 10. All right. What that means basically is you are going to find the decimal point and you are going to move it until it is between the final two digits. So you're going to move it until it is between the final two digits. In this case, it'll go right here. All right, so you're taking it, you're moving it to the left, and you're putting it right there. Now, when you move the decimal to the left, you are going to use a positive exponent when you write out the scientific notation. So you're going to the left here. That means you're going to use a positive exponent, and I'm going to explain what that means for you. Also, another simple way to think of it is basically if the number that you're starting with is greater than 1, you'll be using a positive exponent. This is greater than 1. It's a much bigger number, so you're using a positive exponent. So here's how you'll actually write this. You're going to write 1.5, then you're going to write times 10. That's always part of it. You're always writing times 10. Then, now, as far as the exponents and stuff go, you're going to count how many spaces, how many times you moved the decimal point. So you moved it 1, 2, 3, 4, 5, 6. So you'll write 1.5 times 10 to the 6th. It is a positive 6 because you moved the decimal to the left. Your number that you started with was bigger than 1, is greater than 1. All right, so that's how you do this. So you went from decimal form to scientific notation. Now, something to understand, a lot of kids, this always bothers them, is basically that these two numbers, they're the same thing. All right, in a lot of cases, some kids think like this is a problem they have to solve. It's like, no, this and this, they are the exact same thing. All right, there's no difference. They're the exact same number. They mean the exact same thing in every way possible. All right, I want you to eventually, someday, hopefully, you'll be able to just say, oh, you know, this and this, like you look at 1.5 times 10 to the 6th and you're like, oh, that's 1.5 million. And you'll just be able to do that. Of course, don't feel like you have to be that level of comfort, but just I want you to understand basically like how this is like how this works and why we're doing this. So let's do another one though. In this case, let's make it a number that is less than 1. So let's say we have this instead. So we got 0. All right. So in this case now clearly we're going to have to move the decimal to the right. So we're going to have to move the decimal to the right. And the way it'll work again, you are going to move the decimal until, and you're going to stop right after you get to the first number. So again, your goal is to turn this thing, you want to move the decimal until you get a number that is greater than 1, less than 10. So let's do that. So we're going to go 1, 2, 3, 4, 5. So we're going to put the decimal there. 4.37. It's greater than 1, less than 10. So you'll write out 4.37. You move the decimal over 1, 2, 3, 4, 5 spots. So you'll do times 10. However, in this case, you moved the decimal to the right. So when you go to the right, that equals a negative exponent. So you're not going to write times 10 to the positive 5. You're going to write to the negative 5th. All right, so if you go to the left, you count the number of jumps and you write to the positive exponent, however many jumps. If you go to the right, it's negative. So we've got that done. So that's how you convert from, decimal form to scientific notation, either way. Now, you'll notice in this case, there was only, so I just wrote 1.5. I didn't include those extra zeros after it. That's fine. You don't have to do that. Notice here, I included the 3 and the 7. I suggest for writing numbers in scientific notation right now, as some of you are just learning this, like if you're comfortable, you can include as many digits as you want. I would just simply suggest always rounding to the second decimal point, the hundredths place. Simply just round to, so like if this had continued on and it was like 4.37251, whatever, just a bunch of decimals, just round it so there's only 2 digits after the decimal point. That is much easier, and it's honestly, it's all you're going to need right now for this class. So that's the beginning. Now, at the same time, what I'd like to do, just to sort of help you with this, I want to go over 3 of the first 3 problems from your homework. I just kind of want to go through that with you and like walk you through it. Just do that. So to begin with here, we've got 107,000. So there's no decimal point there, so we're going to add it in. All right. In this case, then we're going to move it over till we get a number greater than 1, less than 10. So we're going to go 1, 2, 3, 4, 5. So we're going to put it right there. Now, I will write out 1.07. Notice I'm including, like I said, I'm rounding to the second decimal point, the hundredths place. So 1.07, I moved it over 5 spots, so times 10 to the 5th. That's all you do. Since you moved it over to the left, again, you're going to have a positive exponent. So number 2 now, start here, and you've got decimals right here. This is a number that is less than 1. You clearly are going to have to move the decimal to the right. So you're going to go 1, 2, 3, 4. All right, so you move it 4 over. You now have a number bigger than 1, less than 10, 8.36. Right, times 10, and you moved it over 1, 2, 3, 4 spots to the negative fourth. The reason it's negative is, again, you went to the left, so it becomes negative. And then the last one here, same deal. We're just going to go 1, 2, 3, 4. Now this can be a little confusing because you'll start to see like, oh, there's all these digits and extra numbers, and it's like, that's okay. You just want to move it over till you have a number greater than 1, less than 10. 1.003 is greater than 1, so you're good. So you'll write it out. Now, in this case, this is where you can get confused. I'm just going to write 1.00. I'm not going to include that 3 because I'm rounding to the hundredths place. I'm rounding to this second digit after the decimal point. So since it's 3, I'm going to round down to 0. If it was greater than 4, or if it was greater than 5, I would have rounded up to 1.01. But it's not, so I'm just going to write 1.00. Then we're going to write times 10. Again, this is 1, 2, 3, 4, so to the negative fourth. So these happen to be the same exponent. Again, you went to the right, so negative. So that's the basics for converting from something in decimal form to scientific notation. All right. And that's really all I want you to worry about today. That's sort of just the basic goal of this lesson, is that you can do that you feel comfortable looking at a number in scientific notation, and you go through and you do that. I don't want you to worry too much about understanding this, like, to where if numbers aren't your thing, I don't want you to freak out and think that this is crazy hard, this is super difficult. No, nothing like that. You will be fine. All right. Now, I'm available to help you whenever you need, so you can email me on this if you need help. The final thing that I want to do before I end this, like, if you're good, just go start working. The final thing I want to do, just really quickly, I would like to review, just do an example of how to convert from scientific notation back to decimal form. This isn't something you'll really need to do that often. I don't even like showing it that much, because I encourage you, if you are comfortable with numbers and you are comfortable with this, do everything in scientific notation. There's a way you can turn your calculator to actually do everything in scientific notation. I mean, it's a little excessive. It's not something I would really suggest you do, because, I mean, if you want to do like 3 times 4, if you type it in your calculator and you change those settings, it'll do 3 times 10 to the 0, times 4 times 10 to the 0. It's just, it's a little excessive. But I just do want to show you this one time, just, so you can know how to do it, basically. So let's say I'll do number 1 directly off of your homework. So number 1 is 1.5 times 10 to the third. So in this case, the way I'm going to write this, I actually like to write it out again down here. I'm just going to write 1.5, and it's 10 to the third. That means that it's positive 3. That means we have a number that is it's greater than 1. That means we're going to move the decimal this way. So we're going to go 1, 2, 3. So if it's positive, you go to the right there. That was like when you're converting back from scientific notation to decimal, you go to the right when it's positive. That can be a little confusing, since you go to the left, it's negative. Since you go to the left, it's positive when you're converting from decimal to scientific notation. That's why I don't like getting into this too much, because the other part of this is more important, to be completely clear. Converting from decimal form, from numbers to scientific notation, that's just more important. So I will show you this, but you're just going to move the decimal over 3 spots. It's positive, so you move it over 3 spots to the right. You will put in zeros there, and then you just got your number, 1,500. Another example, let's say it was the same problem. This is number 2, but with a negative exponent. And the lights just shut off while I was recording. Isn't that cool? Let's turn the light on like that. All right. So next time I will somehow try to set it so that the lights don't shut off in the middle of a video. I have no control over that though. So anyway, now you're at 1.5. You got a negative 3. So I again rewrite it like this. But in this case, since it's a negative 3, you're going to move it over the other way. You're going to go 1, 2, 3. Negative implies that you have a number less than 1. It means you have a decimal. So we'll fill in zeros here. Put our little dot there. So it'll be, in this case. I don't like to just write a number starting with a decimal, so I'm always going to include an extra 0 there. So 0.0015. All right. So I hope that helps. If you have any questions, like I said, email me, and please make sure you get your work.